So we will be looking at the solutions to algebraic and transcendental functions. Algebraic, this is Maths 209. Again, we're treating Maths 209, algebraic and transcendental equations. So we know that there are some numerical methods. Did you see that? There's some numerical methods for solving algebraic and transcendental equations. There are some numerical methods that's so an equation is said to be algebraic if f of x is equals 0, like your polynomials, your quadratic. For example, when you have something like this, 2x squared plus 5x plus 7, this equation is said to be algebraic as long as it can be equated to 0, right? And we find out that a transcendental equation may consist of other functions if f of x contains, did you see that, contains other functions. If f of x contains other functions, then we can call it a transcendental equation. E.g., if it contains a trigonometry, example, trigonometry, logarithm, an exponential function, and etc. So all these will be classified as a transcendental function. So for example, if we have 4 tan 3x, 4 tan 3x is a transcendental function. Why? It's already containing a trigonometry. It also contains an algebra. Alright? When we have something like e to the power of x is equal to 4x, this is a transcendental function. Why? It's containing an exponential and also containing an algebra. So when it contains other function, when an equation contains other function, we will say that this equation is classified as transcendental equation. So today, without wasting much of our time, we'll be looking at some concepts or some methods. There are several methods that is used to solve transcendental functions. There are several methods that we use to solve transcendental functions, one of which include, number one, we call something the bisection method. We can also use the Newton-Raphson's method. Did you see that? The Newton-Raphson's method. We can also use what we call the Aitken's method. Did you see that? There's also something called the regular Fauci's method. False position method. So we'll be looking at all these things. There's another one called the fixed point method. Fixed point method. So we'll be looking at them one after the other. So we want to start with what we call the bisection method. That's what we're going to start with. I want to start with the bisection method. Let's start with the bisection method. So the bisection method, as it were, the bisection method is also called the method of repeated halves. It's also called the method of repeated halves. Did you see that? Method of repeated halves. And so let's consider that f of x is equal to 0 where, do you see that? Where f of x is continuous, where f of x is continuous on a point a comma b, on a point a comma b, and f of a when multiplied by f of b is less than 0. So it means that to find a root lying between the intervals, then we shall be dividing the intervals into halves. So basically, whatever I'm saying here is just the whole grammar, or the whole point of what I'm saying in bisection method is that for us to solve a question with bisection method, we must not forget what is called the Descartes rule. There's something called the Descartes rule of signs. And this Descartes rule of signs states that f of a when multiplied by f of b should be less than 0. We must not forget this law. For every question I want to solve, I will always be referring to this particular law. For every question we want to solve, I will always be referring to this particular law. So, without wasting much of our time, let us look at a question. Let's look at a question together. Bisection method. How do we solve bisection method? Let's use a sample question. Example: we want to solve x to the power of 3 minus 9x plus 1 is equal to 0 using bisection method, right? And they said the root lies between 2 and 3. The root lies between 2 and 3. And he said correct. Did you see that? He said correct to 3 significant figures. Correct this to 3 significant figures. To solve this problem, the first thing we're going to do, so step 1. You remember I said these two people are called interval of operation, A and B. This is called A and this is called B. So to solve this question, the first thing, we test each interval. So test for A, and A is 2. So let's test A into this function. Once you test A, that means you are doing f of 2. And what does f of 2 means? F of 2 means place these 2 inside this function. So we have 2 raised to the power of 3 minus 9 into bracket 2 plus 1. What will our answer be? Our answer will be minus 9. Did you see that? Now, the next step is to what? Step 2. That's f of what? F of 3. We're testing B now. Test for, let me write it out. Let's write it out. Test for B. And what is B? B is 3. So we are placing 3 into the function. That's 3 to the power of 3 minus 9 into the bracket of 3 plus 1. So when you test for B, what are you going to have? What is your answer? Your answer will be, that's f of 3 is 1. And so step 3 is to utilize Descartes rule. Descartes or Descartes rule, anyone you call it, which states that f of A when multiplied by f of B should be less than 0. So let's check that out. Minus 9, which is f of A. F of A, remember that A is 2. So A is 2. So f of 2 is minus 9. So minus 9, by the time you multiply minus 9 with 1, what is your answer? Minus 9. Is it less than 0? The answer is yes. It's less than 0. So if it is less than 0, it means those two intervals qualify. So we call let x naught be 2, x1 be 3. So in a progressive scheme, if here is x naught, the next person should be x1, the next person should be x2, and so on and so forth. Is that not? Alright. So now that we have x naught to be 2, x1 to be 3, what is our progress? What should be our progressive scheme? The next person should be x2. And so to do that, x2, our x2 will now be x naught plus x1 all over 2. That's why the name, that's where the name bisection came in. Bisection method. That's why the name bisection method came in. So bisecting. And what makes you bisect? The fact that you can what? Qualify them for Descartes rule. If you have not qualified them for Descartes rule, you don't have the right to bisect. If you have not done what? If you have not qualified them for Descartes rule, you don't have the right to bisect. And so we said 2 plus what? 3 divided by 2. We're going to have 2.5. We're going to have 2.5. Alright? Now this Descartes rule is also known as Descartes rule of sign, where you have one positive, one negative. That's the full name of Descartes rule. You must have one positive and one negative. Okay, just like you have it here. F of A is a minus, f of B is a positive. One negative, one positive. One negative, one positive. What is the aim of doing that? So that when you multiply them, they will be less than 0. Did you see that? They will be less than 0. And so you cannot use these two intervals if you have not qualified them for Descartes rule. And so x2 will be 2.5. So what do we do from here? We say f of x2. Did you see that? F of what? X2. What does it mean to say f of x2? Placing this 2.5 into the parent equation. Look at the equation. This is where the whole problem started. Placing this 2.5 inside here. And so what would you have? You have 2.5 all to the power of 3 minus 9 into bracket 2.5 plus 1. So if you punch your calculator for that, you're going to have minus 5.8. Minus 5.8. You'll be having minus 5.8. That's f of x2. Now, just like I said that in Descartes rule, you must have one positive, one negative. Now, since this person is a negative, and we said Descartes rule f of a when multiplied by f of b should be less than 0, we need one positive to qualify these people for Descartes rule. True or false? So we'll ask ourselves, when was the last time we saw a positive figure? The last time that we saw a positive figure is this person, which is f of 3. Did you see that? F of 3 was what? 1. So we said, let's clean this part. We said, since f of 3, which was 1, when multiplied by f of what? 2.5 is less than 0, then we now say that what? And this is x. Now we have in our bracket, we have x naught to be 2, we have x1 to be 3, we have x2 to be 2.5. So you know, this is x2, 2.5. We are going to what now? X3. True or false? We are progressing. Is that not? So since f of x3 multiplied by f of 2.5 was less than 0, then x3 will be, I hope you are seeing that now, x3 will be 2.5 plus 3. Did you see that? Or you can say x1 plus x2 divided by 2, as the name implied, bisection. So we are dividing, and so you will now say that what? x1, which is 3, when added to x2, which is 2.5, should divide 2. And so 3 plus 2.5 divided by 2, our answer will be 2.75. 2.75. Can you see that? Now, what's the next thing you do? You have gotten, for every x that you get, you must get their f's. Let me repeat that. For every x for every x that you must get their f's. So for you to remember, after getting x3, the next thing I'm supposed to do is to get f of x3. So let's clean the board. So we are saying f of x3 means that put this thing inside the parent equation. And don't forget, the parent equation was x raised to the power 3 minus 9x plus 1. This was the parent equation. This was where all the drama started. So f of x3 is you doing what? Putting this into the parent equation. And so we find out that we have 2.75 all to the power of 3 minus 9 into bracket 2.75 plus 1. That's f of x3. And what will you have here? F of x3? You're going to be having a minus 2.9 f of x3. Now, the next question you ask yourself is, this person is a negative. I told you before you go to the next step after this, after finding the f's, before you go to the next step, you must check for Descartes' rule. You must do what? Check for Descartes' rule. So, now, how do we check for Descartes' rule from here? Now that we have a minus 2.9, how do we then check for a Descartes' rule from here? We say, since this is a negative, we look for somebody who once gave us a positive at their f's. We look for somebody who once gave us a positive so that we can do a Descartes' rule. And then we check who was the last person to give us a positive at their f's. The last person to give us a positive was this man, 3. Because f of 3 was what? 1. Is that clear? F of 3 was what? Was 1, if you can remember. So we now say that was, since f of x3 when multiplied by f of x 1 is less than 0. Why did I not use x2 here? I didn't use x2 because this person is a negative. And so negative cannot work with negative. We need one negative and one positive. Is that clear? So since f of x3 when multiplied by f of x1 is less than 0, then we can now say that x4 is equal to x3 plus x1 divided by 2. And what is x3? 2.75 plus, what is x1? x1 is 3. Can you see? 3 divided by 2. So what are you going to have? You're going to have 2.88. 2.88. What do you do from here? For every new child that is born, for every new x's that are born, you find their f's. Did you see that? For every x that you get, you find their f's. So the next thing that will occur to us to do is to find f of x4. F of x4, which means placing this newborn baby that you just got into the parent equation where the problem started from. And so you say 2.88 all to the power of 3 minus 9 into bracket 2.88 plus 1. So this is where I chip in something. I said you must mind what the question say. If the question say at 4 iteration, you stop at x4. This will be your answer at 4 iteration. If the question say at 5th iteration, you must stop at x5. If the question say at 6th iteration, you must stop at x6. But because this question said, this question does not specify, right? It didn't specify where to stop. It didn't specify where to stop. So you continue onto a point where the last answer you got and the next answer you are going to get is the same thing. All right, is the what? Same thing. Now, if you look at the trend, x3 is 2.75, x4 is 2.88. They are getting closer, right? 2.88, 2.75. It's getting close. So let's look at it together. F of x4 is now what? F of x4 will now be minus 1.03. Minus 1.03. So what do? the next thing to do is to qualify Descartes' rule again. And then we ask ourselves, how do we qualify a Descartes rule? You said, since this person is a negative, you need a positive to counteract this person. Because Descartes' rule said f of a, when multiplied by f of b, should be less than 0. Is that not what Descartes said? So you need somebody to counteract this person. So what was the last person that gave you a positive? F of who? That's the question you ask yourself. F of who gave you a positive that you can use to counteract this f of x4? The answer is x1. F of what? x1. F of x1 gave you. So you now say, since, did you see that? Since f of x4, when multiplied by f of x1, was less than 0. Descartes' rule. Since f of x4, when multiplied by f of x1, is less than 0, then we can now say that x5, x5 is equal to x4. The people you called here, x4. And what is x4? x4 plus x1 all divided by 2. And what is x4? x4, your x4 is 2.88 plus, what is your x1? Your x1 is still 3 divided by 2. What are you going to have here? You'll have 2.94. 2.94. So for the sake of this question, we'll stop at 5th iteration at x5. So we can now say that, so 3 significant figure. Don't forget, the question says 3 significant figure. So 3 significant figure. You see that the root of the equation x raised to power 3 minus 9x plus 1 is, this equal to means is, the root of this equation is 2.94. Did you see that? 2.94. And it's correct, since they say it must lie between the interval of a and b. And what was the interval at first? The interval was 2 and 3. Can you see that you can find 2.94 in this region? 2.94 will exist between 2 and 3. That is all about bisection method. I hope you understand. See you in the next class.